Welcome to sureshbhattclasses. We are solving questions on quantitative aptitude topic H.C.F and l.c.m. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, RRB, Railways, Bank PO and many government job exams and job interviews. The topics of quantitative aptitude are also useful for many entrance exams like GRE, GMAT, CAT, SAT, ACT and many more. In this video, we are solving questions on LCM. Our question is, find the least perfect square number which is exactly divisible by 4, 5, 6, 8 and 10. The given options are option A 2500, option B 1600, option C 900, option D 3600. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. First we will find the LCM of given numbers. The given numbers are 4, 5, 6, 8 and 10. As 4 is already included in 8 and 5 is already included in 10. So we will find the LCM of 6, 8 and 10. We find the LCM by common division method. We first divide these numbers 6, 8 and 10 by 2. 2 divides 6 for 3 times, 8 for 4 times and 10 for 5 times. LCM equal to 2 multiplied by 3 multiplied by 4 multiplied by 5. To make this number perfect square, what we have to do? We have to make pair of each number which is not a perfect square. Here 4 is perfect square. 2, 3 and 5 are not perfect square. So we'll have to multiply it by 1, 2, 1, 3 and 1, 5. So the required number will be 2 multiplied by 2. Now it becomes a square. Multiplied by 3 multiplied by 3. Now 3 multiplied by 3 is a perfect square. Now 4 is a perfect square, so we are not to multiply any 4 to it. Now we multiply 5 to 5 to make it a perfect square. Now this is equal to 2 5s and 2 2s make 100. And now we will multiply the balance numbers. 4 multiplied by 3 is 12. 12 times 3 is 36. And 36 multiplied by 100 is 3600. And 3600 is a perfect square. And this is divisible by 4, 5, 6, 8 and 10. And from the given options, our answer is option D 3600. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, what is the smallest number which when increased by 7 is divisible by 24, 30, 32 and 36? The given options are option A 1525, option B 1433, option C 1267, option D 1653. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. First I will explain how to solve this question from the given options. The given numbers are 24, 30, 32 and 36. Here 36 is divisible by 9. It means that in the given options, if we add 7 to the option and we divide that number by 9, and if it divides, that might be our answer. If we add 7 to 1525, it becomes 1532. If we add the digits, 1 plus 5 is 6, 6 plus 3 is 9, plus 2 is 11, and this number is not divisible by 9. So option A cannot be our answer. Option B, 1433. If we add 7 to it, it will be 1440. The sum of digits, 1 plus 4 is 5, plus 4 is 9. This is divisible by 9. So option B might be our answer. Now we go to option C. 1267 plus 7 is 1274. If we add the digits, 1 plus 2 is 3, 3 plus 7 is 10, 10 plus 4 is 14, and 14 is not divisible by 9. So this number is also not divisible by 9. Therefore, option C cannot be our answer. Now we go to option D. If we add 7 to 1653, it becomes 1660. And if we add the digits, 1 plus 6 is 7, 7 plus 6 is 13, and 13 is not divisible by 9. So option D cannot be our answer. It means that option B must be our answer. I hope you have understood the method for solving from the options. Now we solve it by regular method. I will erase these numbers. Now we will find the LCM by shortcut method. We will choose the largest number, which is 36. 36 is 4 multiplied by 9. And next number is 32, which is 4 multiplied by 8. 4 is already included in 36 and 8 is not included in 36. So we multiplied by 8. Now 36 multiplied by 8 includes 36 and 32. Now 24. 24 is 6 multiplied by 4. 6 is included in 36 and 4 is included in 8. So 24 is also included in this. One more number left is 30. 30 is 6 multiplied by 5. 6 is included in 36. So we have to multiply it by 5 so that 30 is also included in these multiplications. Now this is our LCM. 8 times 5 is 40. We put 0 of 40 at the end, and 36 multiplied by 4 is 144. So our number is 1440, and our answer will be 1440 minus 7, as we have to subtract 7 to satisfy the given condition in the question. So this becomes equal to 1433, and this is our answer, which is option B. Now we will solve this question by regular common division method. We write all these numbers: 24, 30, 32, 36. We divide these by 2. 2 divides 24 for 12 times, 30 for 15 times, 32 for 16 times, and 36 for 18 times. Now we further divide it by 2. 2 divides 12 for 6 times. We write 15 as it is not divisible by 2. 2 divides 16 for 8 times and 18 for 9 times. We further divide it by 2 as two numbers are there divisible by 2. 2 divides 6 for 3 times. We write 15 as it is. 2 divides 8 for 4 times. We write 9 as it is. Now we divide these numbers by 3. 3 divides 3 for 1 time. 15 for 5 times. We write 4 as it is. 3 divides 9 for 3 times. Now 5, 4 and 3 are co-prime numbers. Now we can multiply and find the LCM. So LCM equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 4 multiplied by 3. 1 5 and 1 2 makes 10. So we will put the 0 at the end and we multiply the remaining numbers. 3 multiplied by 4 is 12. 12 times 3 is 36. 36 times 2 is 72. And 72 times 2 is 144 equal to 144, and we put one more 0 of 5 multiplied by 2. So it becomes 1440. Now our answer is 1440 minus 7, as the given condition is that we have to find that number which on increasing by 7 is divisible by the given numbers. So we will subtract 7 from it and it becomes 1433. And from the given options, our answer is option B, 1433. This is that number which when increased by 7 is divisible by 24, 30, 32 and 36. I hope you have understood all the methods of solving such type of questions. We go to the next question. Our question is, find the greatest 5 digits number which on dividing by 10, 12, 15 and 21 leaves the remainder 9 in each case. The given options are option A, 99,969, option B, 98,989, option C, 99,941, option D, 99,939. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We will first solve it from the given options. As the remainder on dividing by the given numbers is 9. So we first subtract 9 from each option. On subtracting 9 from option A, we get 99,960. Option A. Option B we are going to get is 98980. Option C we are getting is 99932. And option D will be 99930. As the given numbers are 10, 12, 15 and 21, which includes 10. It means that the number after subtracting 9 must end with 0. So option A ends with 0, option B ends with 0, option C does not end with 0 and option D ends with 0. So option C is not possible. So we cancel option C. Now as one number is 12, which is divisible by both 4 and 3. So these numbers must be divisible by 4. Option A ends with 60, so it is divisible by 4. Option B ends with 80, so it is divisible by 4. And option D, which ends with 30, which is not divisible by 4. So D cannot be our answer. Now we will take the sum of the digits to find the divisibility by 3. 9 plus 9 plus 9 is 27. Plus 6 is 33. This is divisible by 3. So option A might be our answer. Now the next number is 98980. 9 plus 8 is 17, plus 9 is 26, plus 8 is 34, and 34 is not divisible by 3. So option B cannot be our answer. The only option left is option A. Therefore, option A must be our answer. So in competitive exams, we can reach to the answer fast without solving the entire question and save our time. I hope you have understood the method of solving the question from the options. Now I erase it and I will show you how to solve it from shortcut. In the given numbers, 21 is the largest number. The next number is 15. 21 is 7 times 3 and 15 is 5 times 3. So 3 is common in 21 and 15. So I multiply it by 5, which is not common in both the numbers. So 15 is included in 21 multiplied by 5. Now 12 is 3 times 4 and 21 is 3 times 7. So 3 is included in 12, which is also included in 21. The number which is not included in 21 is 4. So I multiplied by 4. Now 12 is included in 21 multiplied by 5 multiplied by 4. Now 10. 10 is 5 times 2. 2 is included in 4 and 5 is already there. So 10 is included in 21 multiplied by 5 multiplied by 4. So this must be our LCM. And this is equal to 5 times 4 is 20 and 21 multiplied by 20 is 420. I hope you have understood the shortcut method of finding LCM. If it is difficult for you to find LCM by this shortcut method, then we can also find the LCM by common division method like this. We write all the numbers 10, 12, 15 and 21. Now we find the LCM by common division method. We divide these numbers by 2. 2 divides 10 for 5 times, 12 for 6 times, and we write 15 and 21 as it is. Now we divide these numbers by 3. We write 5 as it is. 3 divides 6 for 2 times. 3 divides 15 for 5 times and 21 for 7 times. Now we divide these numbers by 5. 5 divides 5 for 1 time. We write 2 as it is. 5 divides 5 for 1 time. We write 7 as it is. Now our LCM is 2 multiplied by 3 multiplied by 5 multiplied by 2 multiplied by 7 equal to 7 times 2 is 14. 14 times 5 is 70. 70 times 3 is 210. 210 times 2 is 420. This way we can find the LCM by common division method. Now we have to find the greatest 5-digit number divisible by this LCM 420. The greatest 5-digit number is 99,999. We divide this number by 420. 420 divides 999 for 2 times. 2 times 420 is 840. On subtracting 840 from 999, we get 159. We carry 19 from above. 420 divides 1599 for 3 times. 3 times 420 is 1260. On subtracting 1260 from 1599, we get 339. We carry the last 9 from above. 420 divides this for 8 times. 8 times 420 is 3360. our remainder is 39. We will subtract this 39 from 99,999 and then we will add 9 to it to get our answer. On subtracting 39 we get 99,960. Now we add 9 to it. So this becomes 99,969. And from the given options, our answer is option A, 99,969. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest 5 digits number which on adding 3,897 is exactly divisible by 12, 15, 18 and 20. The given options are option A, 99,983, option B, 99,963, option C, 99,899, option D, 99,937. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We'll first solve it from the given options. As the number is divisible by 12, 15, 18 and 20 on adding 3,897. It means that the number must be ending with 0 because 20 is there. If we add 7 of 3,897 to the last digit of given numbers, then they must be ending with 0. So if we add 7 to 3 of option A, it becomes 10, so it gets 0. Option A might be our answer. If we add 7 to the last digit of option B, 3 plus 7 is again 0. So option B might be our answer. But if we add 7 to the last digit 9 of option C, so it comes out to be 16. 7 plus 9 is 16, which is 6. This is not ending with 0. So option C cannot be our answer. And option D, the last digit of the option D is 7. And if we add 7 to it, it will be 14 or ending with 4. So D cannot be our answer. Our answer must be from option A and B. Now, as 12 and 20 both are divisible by 4. So the last two digit on adding 97 of 3897 must be divisible by 4. So if we add 97 to option A, this comes out to be 7 plus 3 is 0. We carry 1. 9 plus 9 is 18. 80. 80 is divisible by 4. 3 plus 7 is 10. We write 0 and carry 1. 9 plus 1 is 10 plus 6 is 16. And we write 6 of 16. 60 is also divisible by 4. Again, I have erased the numbers which I had written. Now, the sum of the digits of 3897 is divisible by 3. So we will check these A and B whether the sum of the digits are divisible by 3 or not. 999983. Option A is not divisible by 3 as the 999 are divisible by 3, but 8 plus 3 is 11, which is not divisible by 3. So only option left to us is option B, and that must be our answer. Then also we check whether it is divisible by 3 or not. So 999 are divisible by 3, 6 is divisible by 3 and 3 is divisible by 3. It means that option B must be our answer. This way we can select our answer in any competitive exams from the given options and save a lot of time of solving the question. Now we find the LCM by common division method. We write the given numbers 12, 15, 18 and 20. We divide these numbers by 2. 2 divides 12 for 6 times. We write 15 as it is, as it's not divisible by 2. 2 divides 18 for 9 times. 2 divides 20 for 10 times. Now still 2 numbers are there which are divisible by 2. 2 divides 6 for 3 times. We write 15 and 9 as it is, as both the numbers are not divisible by 2. 2 divides 10 for 5 times. Now we divide these numbers by 3. 3 divides 3 for 1 time. 3 divides 15 for 5 times. 3 divides 9 for 3 times. And we write 5 as it is. Now we divide these numbers by 5. We carry 1 as it is. 5 divides 5 for 1 time. We write 3 as it is. 5 divides 5 for 1 time. Now our LCM is 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 3. 5 times 3 is 15. 15 times 3 is 45. 45 times 2 is 90. 90 times 2 is 180. So 180 is our LCM. The largest 5-digit number is 99,999 plus the given number which is to be added to this is 3,897. The sum of 99,999 plus 3,897 is 103,896. Now we divide this number by 180. 180 divides 1038 for 5 times. 180 times 5 is 900. On subtracting we get 138. We carry 9. 180 divides 1389 for 7 times. 7 times 180 is 1260. On subtracting we get 129 and we carry 6. Again 180 divides this for 7 times. 7 times 180 is 1260. On subtracting we get the remainder 36. Now we subtract 36 from 99,999. On subtracting 36 from 99,999, we get 99,963, and that is our answer. And from the given options, our answer is option B, 99,963. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest 5 digits number which when divided by 16, 18, 20 and 24 leaves the remainder 7 in each case. The given options are option A, 99,727, option B, 99,367, option C, 99,487, option D, 99,947. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can directly solve this question from the given options. As the remainder is 7 in each case, so we subtract 7 from all the numbers first. Option A becomes 99,720. Option B becomes 99,360. Option C becomes 99,480. Option D becomes 99,940. In the given numbers, the numbers are 16, 18, 20 and 24. As one number is 20 which ends with 0, So all the numbers must be ending with 0 after subtracting 7. So all the numbers are ending with 0. Now, as one number is 18, which is divisible by 9, it means that the option which is divisible by 9 must be our answer. So we check the divisibility by 9. The sum of the digits of option A after subtracting 9 is 99720. So 9 is divisible by 9, 9 is divisible by 9, 7 plus 2 is 9, which is divisible by 9. So option A is divisible by 9. Option B is also divisible by 9. Option C, 9, 9, 4, 8. 4, 8 is 12 and 9, 9 are divisible by 9. But 12 is not divisible by 9. So option C is not divisible by 9. So option C cannot be our answer. Option D, 9, 9, 9, 4, 0. The 3 9s are divisible by 9, but 4 is not divisible by 9. So option D is not our answer. It means that our answer must be from option A and option B. Now, how to find the correct answer out of these two? As the number is divisible by 16, it means that the last 4 digits must be divisible by 16. The last 4 digit of the option A after subtracting 7 is 9720. And when we divide it by 16, 16 times 6 is 96. The remainder is 1. We carry 2. Then it becomes 12. 12 is not divisible by 16. We carry one more 0. So it will be 120. And 120 is not divisible by 16. So option A cannot be our answer. But we check the divisibility by 16. So we will divide the last 4 digits 9360 by 16. 16 times 5 is 80. On subtracting 80 from 93 we get 13. We carry 6, which is 136. 136 when divided by 16. 16 times 8 is 128. On subtracting 128 from 136 we get 8 and we carry 0. And the number becomes 80. And 16 times 5 is 80. So option B must be our answer. This way we can find our answer using the property of numbers. When we reach to the answer from the options, then we have not to solve the question and we can directly select our answer in any competitive exams and save our time. Now we solve this question by regular method, because if more than one option satisfies all these conditions, then we have to solve it by regular method. So we must learn the regular method as well. Now I erase all these numbers. Now we will find the LCM by shortcut method. The largest number is 24. The second largest number is 20. The common number between 20 and 24 is 4. 4 times 6 is 24 and 4 times 5 is 20. So we multiplied by 5 so that 24 and 20 both are included in 24 multiplied by 5. The next higher number is 18. 18 is 9 times 2, which is 3 multiplied by 3 multiplied by 2. So 1 3 is included in 24, 1 2 is included in 24. 1 3 is not included in 24, so we multiplied by 3. Now 16 is 8 times 2. 1 8 is included in 24, 8 times 3 is 24. So we have only to multiply it by 2, so include our 16 in this multiplication. And this is our LCM. 24 times 5 is 120. 120 times 3 is 360 and 360 times 2 is 720. So the LCM is 720. This is the easiest method of finding the LCM if you are quick in calculations. But if you are not very good in understanding the factors and multiplication, then you should go with the regular common division method. So we'll solve it by common division method and finding the LCM. We write all these numbers 16, 18, 20 and 24. We divide these numbers by 2. 2 divides 16 for 8 times, 18 for 9 times, 20 for 10 times and 24 for 12 times. We again divide it by 2. 2 divides 8 for 4 times. We write 9 as it is. 2 divides 10 for 5 times. 2 divides 12 for 6 times. Further we can divide it by 2. 2 divides 4 for 2 times. We write 9 as it is. We write 5 as it is. And 2 divides 6 for 3 times. Now there are two numbers divisible by 3. So we divide it by 3. We write 2 as it is. As it is not divisible by 3. 3 times 3 is 9. We write 5 as it is. 3 times 1 is 3. Now 2, 3 and 5 are co-prime numbers. Now we can calculate our LCM. LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 3 multiplied by 5. 5 times 3 is 15. 15 times 2 is 30. 30 times 3 is 90. 90 times 2 is 180. 180 times 2 is 360. And 360 times 2 is 720. 720 is our LCM. Now we divide the greatest 5-digit number, which is 99,999 by 720. 720 divides 999 for one time. On subtracting 720 from 999, we get 279. We carry 1 9 from above. 720 divides 2799 for 3 times. 720 times 3 is 2160. On subtracting we get 9 minus 0 is 9. 9 minus 6 is 3. 7 minus 1 is 6. And 2 minus 2 is 0. We carry 9 from above. 720 divides 6399 for 8 times. 8 times 720 is 5760. Our remainder is 639. We subtract 639 from 99,999 and then we will add 7 to it. On subtracting 639 from 99,999, we get 99,360. Now we add 7 to it, as we want the remainder 7 in each case. So this becomes 99,367, and this is our answer. And from the given options, our answer is option B, 99,367. I hope you have understood all the methods of solving such type of questions. We go to the next question. Our question is, find the smallest 5 digits number which, when decreased by 13, is divisible by 14, 16, 21 and 24. The given options are option A, 10,183, option B, 10,317, option C, 10,093, option D, 10,169. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We'll first solve it from the given options, as the number has to be decreased by 13. So we subtract 13 from each option. On subtracting 13 from 10183, we get 10170. On subtracting 13 from 10317, we get 10304. On subtracting 13 from 10093, we get 10080. And on subtracting 13 from 10169, we get 10156. Now our answer must be divisible by 3 as well as by 4. As the last two digits of the option A is not divisible by 4, so option A cannot be our answer. Option B, the last two digits are divisible by 4, so B can be our answer. The last two digits of option C is divisible by 4, so option C can be our answer. Option D, the last two digit 56 is divisible by 4, so option D may be our answer. So option A cannot be our answer. Now we have eliminated one option. Now we find the sum of the digits. 1 plus 3 is 4 plus 4 is 8. It's not divisible by 3, so B cannot be our answer. 1 plus 8 is 9. It's divisible by 3, so C may be our answer. Now we find the sum of the digits of option D. 1 plus 1 is 2. 2 plus 5 is 7. 7 plus 6 is 13. And it's not divisible by 3. So D cannot be our answer. The only option left is option C. That must be our answer. I hope you have understood how to find the answer from the given options. If you are able to get our answer from the options, then we can directly select that answer and move to next question in any competitive exams and save our time. Now I erase this portion and we will solve it by the regular method. Now we will find the LCM of 14, 16, 21 and 24 by shortcut method. The largest number is 24, so I write 24. Now the next largest number is 21. The only common thing in 24 and 21 is 3. So 8 times 3 is 24 and 7 times 3 is 21. So 7 is not included in 24. So we multiplied by 7. 24 multiplied by 7 includes 24 as well as 21. Now the next number is 16. 24 is 8 times 3 and 16 is 8 times 2. So 8 is included in 24 and 16. 1, 2 is left in 16 which is not included in 24. So we multiplied it by 2. Now 14. 7 multiplied by 2 we already have in our multiplications. So 14 is included in 24 multiplied by 7 multiplied by 2. So this is our LCM. 7 times 2 is 14. 14 times 4 is 56. We write 6. We carry 5. 14 times 2 is 28. Plus 5 is 33. So our LCM is 336. If you are unable to find your LCM by the shortcut method, then you should go by regular common division method. So we will find the LCM from common division method as well. We write all these numbers 14, 16, 21 and 24. We divide these numbers by 2. 2 divides 14 for 7 times. 2 divides 16 for 8 times. We write 21 as it is. 2 divides 24 for 12 times. Still two numbers are divisible by 2. We write 7 as it is, as it's not divisible by 2. 2 divides 8 for 4 times. We write 21 as it is, as it's not divisible by 2. 2 divides 12 for 6 times. Still two numbers are there divisible by 2. We write 7 as it is. 2 divides 4 for 2 times. We write 21 as it is. 2 divides 6 for 3 times. Now two numbers are divisible by 3. So we divide these numbers by 3. We write 7 as it is. 2 as it is. 3 divides 21 for 7 times. And 3 times 1 is 3. Now we divide these numbers by 7. 7 divides 7 for 1 time. We write 2 as it is. 7 divides 7 for 1 time. Now we multiply all these numbers. 2 times 7 is 14. 14 times 3 is 42. 42 times 2 is 84. 84 times 2 is 168. And 168 times 2 is 336. So our LCM is 336. Now the least 5-digit number is 10,000. We divide 10,000 by 336. 336 divides the initial 4 digits 1000 for 2 times. 2 times 336 is 672. On subtracting 672 from 1000, we get 328. We carry 0 from above. 336 divides 3280 for 9 times. 9 times 336 is 3024. On subtracting 3024 from 3280, we get 256. We subtract 256 from 10,000 and we add 336, and we also add 13 to get our answer. 336 minus 256 is 80. 80 plus 13 is 93. 93 plus 10,000 is 10,093. And from the given options, our answer is option C, 10,093, which is that number which when decreased by 13 is divisible by 14, 16, 21 and 24. I hope you have understood all the methods explained by me in solving this question. We go to the next question. Our question is, find the greatest 4 digits number exactly divisible by 24, 28, 32 and 36. The given options are option A, 9,984, option B, 9,996, option C, 9,974, option D, 8,064. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can find the answer from the given options as the number is divisible by 24, 28, 32 and 36. 36 is 9 multiplied by 4. It means that our answer must be divisible by 9. So we find the sum of the digits. The sum of the digits in option A. The first digit 9 is divisible by 9. The second digit is divisible by 9. And 8 plus 4 is 12, which is not divisible by 9. So option A cannot be our answer. Option B. The first 3 digits 999 are divisible by 9. And the last digit 6 is not divisible by 9. So option B cannot be our answer. Option C, first 2 digits 9 are divisible by 9 and 7 plus 4 is 11, which is not divisible by 9. So option C cannot be our answer. The only option left is option D. So we check for it. 8 plus 6 is 14 plus 4 is 18. 18 is divisible by 9. So option D, must be our answer. Now we solve it by regular method. We find the LCM by common division method. We write all these numbers 24, 28, 32, 36. All these numbers are divisible by 4. So we divide it by 4. 4 divides 24 for 6 times, 28 for 7 times, 32 for 8 times, and 36 for 9 times. Now two numbers are divisible by 2. So we divide it by 2. 2 divides 6 for 3 times. We write 7 as it is. 2 divides 8 for 4 times. We write 9 as it is. Now we divide these numbers by 3. 3 divides 3 for 1 time. We write 7 as it is. We write 4 as it is. 3 divides 9 for 3 times. Now 7, 4 and 3 are co-prime numbers. So we now directly multiply these numbers to find our LCM. 3 times 4 is 12. 12 times 7 is 84. 84 times 3 is 252. 252 times 2 is 504. And 504 times 4 is 2016. Therefore, our LCM is 2016. Now the greatest 4-digit number is 9999. We divide this number by our LCM 2016. 2016 divides 9999 for 4 times, and 4 times 2016 is 8064. 8064 when subtracted from 9999 we get 1935. This 8064 is our answer, as 9999 minus 1935 is 8064. And from the given options, our answer is option D, 8064, which is that greatest number of 4 digits exactly divisible by 24, 28, 32 and 36. I hope you have understood both methods of solving this question. One was from the given options and other the regular method. We go to the next question. Our question is, find the least perfect square number which is exactly divisible by 15, 16, 20 and 24. The given options are option A, 6400, option B, 4900, option C, 2500, option D, 3600. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We first find the prime factors of the LCM of given numbers. We write all these numbers 15, 16, 20 and 24. We use the common division method to find the factors of LCM. We divide these numbers by 2. We write 15 as it is, as it's not divisible by 2. 2 divides 16 for 8 times, 20 for 10 times, 24 for 12 times. We further divide it by 2. We write 15 as it is. 2 divides 8 for 4 times, 10 for 5 times and 12 for 6 times. We again divide it by 2. We write 15 as it is. 2 divides 4 for 2 times. We write 5 as it is. 2 divides 6 for 3 times. Now we divide these numbers by 3. 3 divides 15 for 5 times. We write 2 as it is. We write 5 as it is. And 3 divides 3 for 1 time. Now we divide by 5. 5 divides 5 for 1 time. We write 2 as it is. 5 divides 5 for 1 time. And we write 1 as it is. Now the factors of our LCM are 2 multiplied by 2 multiplied by 2 and multiplied by 2, which is in last row, which was left undivided, multiplied by 3 multiplied by 5. This is the prime factors of our LCM. Now to make it perfect square, each number must be in a pair. 2 multiplied by 2 is a pair, again 2 multiplied by 2 is a pair, but we need 1 3 and 1 5 to make it a pair so that it becomes a perfect square. So we multiply these by 1 3 and 1 5. 5 times 3 is 15. 15 times 15 is 225. 225 times 2 is 450. 450 times 2 is 900. 900 times 2 is 1800. 1800 times 2 is 3600 or 3600. This is that least perfect square number exactly divisible by 15, 16, 20 and 24. And from the given options, our answer is option D, 3600. I hope you have understood the method of finding the answer to such type of questions. We go to the next question. Our question is, find the least number exactly divisible by 32, 45, 60, 72 and 80. The given options are option A 1400, option B 1420, option C 1460, option D 1440. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can solve this question from the given options. As one of the numbers is 72, which is multiple of 9, and from the given options our answer must be divisible by 9. In option A, the sum of the digits is 1 plus 4 is 5, which is not divisible by 9. In option B, 1 plus 4 is 5 plus 2 is 7. This is not divisible by 9. In option C, 1 plus 4 is 5. 5 plus 6 is 11. This is also not divisible by 9. Then only option left is option D. 1 plus 4 is 5 plus 4 is 9. This number is exactly divisible by 9. It means that option D must be our answer. And if we are able to reach to our answer from the given options, then we should directly select that option and move ahead for the next question and save time in any competitive exam. Now we solve it by regular common division method. 32, 45, 60, 72 and 80. Except 45, all the numbers 32, 60, 72 and 80 are divisible by 4. 4 divides 32 for 8 times. We write 45 as it is. 4 divides 60 for 15 times. 4 divides 72 for 18 times. And 4 divides 80 for 20 times. Now we divide these numbers by 2. 2 divides 8 for 4 times. We write 45 as it is. We write 15 as it is. 2 divides 18 for 9 times. 2 divides 20 for 10 times. We further divide this number by 2. 2 divides 4 for 2 times. We write 45 as it is. We write 15 as it is. We write 9 as it is. 2 divides 10 for 5 times. Now we divide it by 3. We write 2 as it is. 3 divides 45 for 15 times. 15 for 5 times. 9 for 3 times. We write 5 as it is. We further divide it by 3. We write 2 as it is. 3 divides 15 for 5 times. We write 5 as it is. 3 divides 3 for one time. We write 5 as it is. Now we divide it by 5. We write 2 as it is. 5 divides 5 for one time. 5 divides 5 for one time. We write 1 as it is. 5 divides 5 for one time. Now our LCM is 4 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 2. Now we leave 5 multiplied by 2 is 10, and we multiply all other numbers, and then we will add 1 0 to that multiplication to get our product of these numbers. 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. 36 times 4 is 144, equal to 144, and we multiply it by 10. So we write 1 0 after 144. So it becomes 1440 or 1440. And from the given options, our answer is option D, 1440. This is that required number which is exactly divisible by 32, 45, 60, 72 and 80. I hope you have understood the method of solving such type of questions. Please do a lot of practice from different books and solve as many questions as possible of quantitative aptitude topics. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.